Okay, good morning, good morning. So we can wait for 2 minutes, let other to join, then we can start the today's topic. Okay, wait for 2 minutes. In the meantime, everyone should join. Okay, so we can start the today lecture. Okay. So let me on the good morning, everyone. You. Okay, so in the last class, I have covered the distance matrices. Okay. Uh, okay. So in that, someone has asked me about the uh, about Minkowski and how to decide the h in Minkowski. Okay, in Minkowski distance, how to decide by the how to decide h. Okay, so we will see today this. Then after that, we will move to the another numerical part. Okay. So whenever we are talking about Minkowski distance, sorry. So can anyone tell what is the formula for the Minkowski distance? Generalized formula. So we have the 2 point like distance x comma y. Then what we can say? It is a summation I is equal to 1 to n mod xi minus sorry yi. It is yi to the power h by to the power 1 by h. This is the formula. Everyone is clear with this formula? यही एक फॉर्मूला था, ठीक है. So when we talk about h, so this is the when we in some book you can see it is also denoted by p. Okay, so when we talk about h or p, it controls the order of norms and significantly affect the affects the behavior of the distance matrix. Okay, we will see that through the graph. We will see how it is affecting that. So always remember, whenever we are talking about this h, this h plays an important role which decides the behavior of the distance matrix. Okay. Now we will see the different value of h. Let me save this slide. So today's date is what is the desktop only. So today's is 9th. Okay. Okay. Now we can see what are the different values of h and what the effect on it. Okay. So we have taken h is equal to 1. Whenever we are taking h is equal to 1, it is telling to calculate the Manhattan distance. Manhattan distance. Because we know that Manhattan distance is what? That is the mod of x2 minus x1 plus y2 minus y1 mod. Okay. So what it is telling when h is equal to 1, we are telling that total absolute distance. Total absolute difference between dimension. This is only we are calculating when we see this. Okay. And another one we are taking h is equal to 2. What is this? This is also called as L1 norm. Okay, remember it. When we are talking this, what is this? This is Euclidean distance, which is also known as L2 norm. What we are doing this? In this, what we are doing? This is in H2. When we are taking to H2, it implies that it is a Euclidean distance, and in Euclidean distance, what we are doing? That is the straight line distance. The straight line distance in Euclidean space. Okay. Now another one, that is the h is equal to infinity, which is also known as L infinity norms. What it is telling? It is telling takes the maximum absolute difference across the dimension. Across any dimension. Okay. These are the interpretations. Now how to choose h? The question arises how to choose h. So next one we can see how to choose h in Minkowski. Okay, that we have to see that. That is the main important things you have asked from me. So we are focusing on this. Okay. So first we have to decide the problem context. Means that on the basis of problems we have to find the h. Means like first problem you can see. When we have the movement in the grid like path, in that h is equal to 1 is more appropriate. Means what? H is equal to 1 means what? Manhattan distance is more appropriate. Grid like path, you can say me. What is the real life example? Can anyone say grid like path? Real life example? Anyone? We can see that city blocks. सिटी में जो हमारा ब्लॉक्स होता है वो क्या होता है? ग्रिड लाइक स्ट्रक्चर में होता है. Okay. So whenever the problems in the problem we have a grid like path and we have to calculate the distance, then we can go for the h is equal to 1, that is the Manhattan. Second one, that is the straight line. The straight line distance. Okay. Then what we are doing? We will take h is equal to 2, that is the Euclidean distance. Okay. Now, if there is the third one, if there is the large difference, means that large difference in any of the features, in any one features, then we can use what? H is equal to infinity. Okay. Are you clear with this? So first of all, we have to see the problem, which type of problem is there. On the basis of that, we will decide the H. Now, second one, that is the second option. What is the second parameter on the which we have to decide the H? That is the feature scaling. Second one is the feature scaling. Always remember, whenever we are talking about Minkowski is distance is sensitive to the scale. So always normalize the data. Always normalize or standardize the data before applying it. Before applying it. Especially h is greater than 1. This is the second. And third one is the experimentation. So what we have to do? Experimentation is what? We can try with the values. Try values, different values. That is 1, 1.5, 2, 3, and validate the performance. And validate the performance. You got the point? Means we can use for 1.5, then we can calculate the value, and after that we can calculate the 2. We can see in which distance its performance will be better. So that is the experimental part. Okay, are you clear with this? Now we can see the graph. So when we see the graph between h and distance, so as that we can see it will be like this. As the h value will be increased, the distance will decrease. Okay, this is the graph. Okay, so I think now, Arnav, are you clear with this? How to select h? Everyone is clear with how to select h in the Minkowski. So, so in the end term, please one numerical question will be sure from this numerical part. Okay. Now we are coming to the next part. That is the next numerical part, which will be from that topic. The question will be in the end term, or for you also to decide that the model is performing well or not. That is the I already told you. Wait a minute. Let me save this. Then so when we are when we are going to the supervised learning, in this we have seen the two techniques. That is the two term. That is the classifications, and one is the regression. So for the classification, how to evaluate the model in the classification evaluation. Same like in the regression also, I told you how to evaluation of the regression part. What are the terms? What are the evaluation metrics in regressions? Can anyone tell? I already discussed in the class or in the lab. What are the evaluations matrices in regression? Anyone who can tell? Yeah, Rishikesh, you are right. That is the MSE, MAE, R2 score, RMSE, adjusted R2 score, So these are the evaluation metrics for the regressions. Now, can anyone tell what is the evaluation metrics for the classifications? Anyone who can tell what are the evaluation matrices for the classification? Anyone? Okay, precision, recall. Okay. So the first thing is the accuracy. Second thing is the confusion matrix. From the confusion matrix only the accuracy will come. Then another one is the precision. Then another one it is the recall. Then we have the F1 score. Okay. So we will see this in details through the numerical problems. Okay, how the numerical problem will come in the accuracy, confusion matrix, precision, then how we will solve that problems. Okay. So today we will cover this. Slide 6. So we can come to the accuracy part. When we talk about the accuracy, let's see one data set. Let's see one output. One output has came. This is the table. So we have the actual value and we have the logistic prediction. Means through the logistic regression what the prediction value has been, and this is the decision tree prediction. Okay, so we have first row, second, third, fourth, fifth, sixth, seventh. So here it is 1. Let me use the marker. So it will be 1. It is 1. Second one it is 0. It is 1. It is 1. Then third one it is 0, 0, 0. Then we have again 0, 0, 0. Then we have 1, 1, 1. Then we have again 1, 1, 1. Then we have 0, 1, 0. Then again we have 0, 0, 0. Let me so it will be 2 हो गया, ठीक है. So now again it will be 0, 0, 0, and it is 1, 1, 1. Now calculate the accuracy of logistic prediction and decision tree prediction. Calculate it. Tell me the answer. What is the answer it is coming? This is the data. This is the output we got from the logistic regression and from the decision tree. Okay, you have to calculate the accuracy. Everyone calculate the accuracy. Everyone calculate the accuracy. Rishikesh, Arnav, Monu. Ayan, what is the accuracy for the logistic prediction and what is the accuracy for the this is the decision tree. Logistic regression model. What is the accuracy of the logistic regression model and decision tree model based on this data set? What is the formula for the accuracy? General formula for the accuracy. Can anyone tell what is the formula for the accuracy? No one has calculated.
The number of correct predictions divided by total number of predictions for accuracy.
Good, then calculate it. Then why you are facing the problem? You know the formula, then why you are facing the problem? You are right.
Sir,
That is
9
accurate.
divided by 9 divided by 10, so it would be around 0.9.
For which one?
So
For for which there is the two model. One is the logistic model and one is the decision tree model. So 90% for the logistic.
for sir logistic regression.
Are you sure?
1 minute, sir. Yes, sir.
Check it. Check it. Check it. For the
So it's
logistic,
80%.
that's why I'm telling you, kindly check it. Only eight prediction is right.
Yes, sir. Sorry, sir.
So for the logistic, you can check it here. So this one is actual is also one and prediction is also one. So it is one correction. Now second statement you can see actual is 0 and prediction is 1. So it is not right. So it is wrong. Actual is also 0 and logistic prediction is also 0. So it is correct. Actual is 0 and logistic prediction is also 0. So it is correct. Again it is 1 1 correct. It is 1 1 correct. It is 0 1 wrong. It is 0 0 correct. It is 0 0 correct. It is 1 1. It is correct. So how many corrects are there? 1, 2, 3, 4, 5, 6, 7, 8. So it is 8. Number of correction is 8. Now total number of term is what? How much? There is how many total number? It is 10. So 8 by 10. So it is 80% correct. Same with the decision tree. You can see 5. How many corrects are there? This is correct. This is wrong. Again, this is correct. This is correct. This is correct. Then again, we can see this is also correct. 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 So it is 9 by 10. So it is 90%. Okay. I am telling everyone kindly focus on this problem because this type of problem will come. And when you understand the theory behind this problem, then only you can do the coding part. Today's in the lab we will do this part only: accuracy, confusion matrix, how to calculate the accuracy, how to generate the confusion matrix. So if you understand the theory part, then only you can implement through the coding. Okay. So this is right. Okay. So we have calculator, and now this is the when we talk about this one, this is for the binary classification. When we see this is for the binary classification. What about the multi-classification? What about the multi-class? So we can see the multi-class also. Now we have seen the iris data. In that, what we have, that is the Satosha flower, which we have taken as a 0. Then we have a Virginica, flower we have taken one, and another one we have the versicolor. We have seen this uh, this data set, that is the iris data set, and we have the output. So we can say that this is the actual, this is the logistic regression, and this is the logistic regression prediction, and this is the decision tree prediction, and this is the actual. So we can see that this is one, two, three, 4, 5, 6, 7, 8, and 9. So we have 0, this is 0, this is 0, this is 0, then it is 2, it is 0, again it is 2, again it is 0, again it is 2 and 1. How many data are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So one more data we can set. So it is 1. So according to this, it is coming 0, 0, 0. It is coming 2. It is coming 0. It is coming. It is coming 2. It is coming 0, 2, 1, 1. And here we can say it is coming 0, 0, 0, 1. It is coming 2. It is 0, 1, 2, 1, 1. Calculate this. Calculate the accuracy. This is the multi-class. So calculate the accuracy for LRP, LR model, and decision tree model. What is the output it is coming? Everyone calculate it. This is a multi-class. Anyone got the answer? No, it is 100%. Okay. So you are telling that the regression model is predicting 100%. Okay. And decision tree is predicting 60%. So everyone is getting this answer? Okay. So right. This is the right answer. Same logic is there when we talk about the binary classification and the multi classification. Same concept we have applied. Okay. Now, when we are talking about the how the accuracy is good, slide 8. Okay. So next question: how much accuracy is good? This is the main problem arises. Okay. So we can say that it depends upon the problem we are solving. It depends on the problem we are solving. Like we can say the system we are making for the system for hospital. Okay. So accuracy is 99%. So we cannot say it is not good, because in the when we talk about exact accuracy, so we can say that, so it depends upon the problem first thing, And another one, it depends upon the data also. Okay. Now the problem with the accuracy, can anyone tell you what is the problem with the accuracy? Anyone who can tell? What is the problem with the accuracy? When we see the accuracy, just only we can see the accuracy, it is a number only. Means that it just means what? Only two things. That is, if we are telling 90% means what? It is telling that 10% is wrong. But why it is wrong, which this cannot be decided by the accuracy. Are you getting what I'm telling? When we talk about the accuracy, it is just a number. Means I'm telling that one model is predicting 90% accuracy. मतलब क्या कि जो मॉडल है वो 10% गलती कर रहा है, पर कहाँ गलती कर रहा है, that is the problem. Means that accuracy is not telling about the type of problem, or type of error. अब आप पूछोगे एरर क्या है, सो वी विल सी दिस. कोई प्रॉब्लम लेके हम उसे एरर देखते हैं. स्लाइड 9. अब देखो कोई एक ले लो, एक एग्जांपल लेते हैं, कैंसर है या नहीं, कैंसर है और नॉट कैंसर. तो यहाँ पे अगर हम देखें तो यहाँ पे दो तरह का मॉडल जो है एरर कर सकता है, टू टाइप्स ऑफ एरर. पहला एरर क्या होगा कि कैंसर, उसे किसी पर्सन को कैंसर होगा और सिस्टम कहेगा कैंसर नहीं है. दिस इज वन एरर. Another one, it is telling that if a person don't have this cancer and the model is predicting that it has a cancer, it is another type of error. हो सकता है मॉडल जो है, अगर मान लो हम एक मॉडल बनाए जो कि डिटेक्ट कर रहा है कैंसर है या नहीं है, और वो हमें प्रेडिक्ट कर रहा है 90%. Okay, it is predicting 90%. But by the 90% we can only decide yes or no. मतलब क्या कि 90% जो है वो करेक्ट बोल रहा है, 10% वो जो है गलत बोल रहा है. पर कहाँ गलती कर रहा है, where it is doing the mistakes that cannot be identified by the accuracy. Means which type of error it is. And error is what? A model is predicting no for the having the cancer and yes for not having the cancer. So this problem is solved by confusion matrix. Okay. So when we see the confusion matrix, it is also telling the types of error and it is also telling about the accuracy also. So we can see this one. This is the confusion matrix. So here we can say it is the binary classification. So in the binary classification we are seeing it is the prediction and this is the actual. It is 1 and 0. It is 1 and 0. Okay. Now this is true positive. This is TP. Means what? हमारा एक्चुअल भी 1 है और प्रिडिक्शन भी 1 है, मतलब 100% मैच कर रहा है. दिस इज ट्रू पॉजिटिव. दिस रीजन इज ट्रू पॉजिटिव. ओके. मतलब क्या कि हमारा जो प्रेडिक्शन भी 1 है और एक्चुअल भी 1 है, दोनों मैच कर रहे हैं. अनदर वन, दिस इज द false positive, that is FP. FP is what? प्रेडिक्शन 1 बता रहा है पर हमारा एक्चुअल जो है वो हमारा 0 है, that is the false. Okay, are you clear with this? Next one is the false negative, that is FN. मतलब क्या, प्रेडिक्शन जो है हमारा निगेटिव बता रहा है पर एक्चुअल जो हमारा पॉजिटिव है जो कि फॉल्स है, दोनों का डिफरेंस है. एंड अनदर वन इज द ट्रू नेगेटिव. हमारा प्रेडिक्शन भी जो है नेगेटिव है, हमारा एक्चुअल भी नेगेटिव है, दोनों ट्रू. So this is the confusion matrix which tells about the types of error, and it is also tells about the accuracy कि कहाँ पे accuracy, and it is also telling about the कहाँ हम गलती कर रहे हैं, where we are making mistakes. Now how to remember it? देखो, अगर प्रेडिक्शन हमारा 1 है मतलब कि पॉजिटिव है, ये देखो पॉजिटिव. अगर ये एक्चुअल के साथ मैच कर रहा है ट्रू, अगर एक्चुअल के साथ मैच नहीं कर रहा है फॉल्स. सो दैट्स व्हाई इट इज ट्रू पॉजिटिव एंड फॉल्स पॉजिटिव. हमारा प्रेडिक्शन क्या है? 0 निगेटिव है, सो इट इज निगेटिव. अगर एक्चुअल के साथ मैच कर रहा है तो निगेटिव ट्रू हो जाएगा, नहीं तो ये फॉल्स होगा. तो अगर हम कहें कि हमारा कोई भी मॉडल जो है, whenever we are talking about अब हमेशा याद रखो कि हम जो है कंफ्यूजन मैट्रिक्स से एक्यूरेसी पे जा सकते हैं, पर एक्यूरेसी से हम कंफ्यूजन मैट्रिक्स पे नहीं जा सकते हैं. दैट इज नॉट द रिवर्स प्रोसेस. दिस यू शुड रिमेंबर. फ्रॉम द एक्यूरेसी, सर मेरे फॉलो हम आपको ये बता देंगे कि ये सब मिल जाता है. आपके पास from the confusion matrix we can reach to the accuracy, but from the accuracy we can't reach to the confusion matrix. Always remember, because accuracy gives the number, whereas confusion matrix give everything, that is true positive, false negative, false positive and true negative. Okay, so always remember this. Okay, now how to calculate this one? So when we see the structure of this in the coding, it will be like the square matrix. 29, 3, 4 and 30. It is 1, it is 0, it is 1, it is 0. Can anyone tell what this square representing? This is square, what this square is representing? Can anyone tell? Or who can write what this 29 is representing? Okay, this square represents confusion matrix, but what this 29 number is representing? What these numbers are representing? 29, 3, 4, 30.
So 29 is the cases which are true, which are accurately diagnosed.
Okay, then what is 30?
30 is the ones which are false, which are accurately predicted as false.
Okay, then what is 3?
Three false negative will be they are true, but they are predicted as false. And four is
They
they
are
are
true.
false. True.
Yeah, they are true, but predicted false. What the case has written, 2 is actual, 9 is predicted. Case we are totally wrong. So here 3 is what? Model has predicted that, like again I'm coming to this part. One example I can give. Okay, so this see this example. The model has predicted 29 times dog, and which is actually 29 times that is dog. The model has predicted 3 times not dog, but it is the dog. So total 30 in the 32 times the model has predicted at 30 in the 32 times dog was there, out of which 29 times machine model has predicted dog, and 3 times it has predicted not dog. Understood? Same way, actually 34 times dog was not there, in which 4 times model has predicted it is dog, and 30 times it has predicted not dog. So that is 34. Okay. Similarly, this way, the model has predicted 33 times dog, out of which 29 times it is a dog and 4 times it is not a dog. Similarly, model has predicted 33 times not dog, out of which 30 is not dog and 3 is the dog. Are you clear with this example, everyone? Kindly go through this. If not understood, you can ask. Kindly go through this example. I am giving you 4 to 5 minutes, 5 minutes to go through this. Understand each number. Okay, have you gone through this example? Everyone, are you clear with this? Everyone, are you clear with this confusion matrix? Numbers 29, 3, 4, and 30. Okay, now we can see the another thing, that is the accuracy. How to calculate the accuracy from this? So what is the accuracy formula? That is number of correct options by total options. So when we see this confusion matrix, this 29 is correct because the model is also predicting dog and actually it is also dog. Similarly, we can say 30 is also correct because the model is predicting not dog and actually it is predicted not dog. So these both value will be higher than the others values. So it is 29 plus 30 by total number of options. So what is the total number of options? This is 29 plus 3 plus 4 plus 30. So this is the accuracy. So we can say that accuracy formula from the confusion matrix, it is TP, it is TN, it is FP, and this is FN. So we can say that TP plus TN, sorry, it is TN by TP plus FN plus FP plus TN. This is the formula for the accuracy. Okay, so we have seen that how from the confusion matrix we have derived the formula for the accuracy. So if I give you the confusion matrix, can you calculate the accuracy? You can calculate it easily. Now we can see the another one, that is the multi-class. Now we can see the confusion matrix for multi-class. So we can see we have the three animals, that is dog, cat, and lion. This is prediction, and this is actual. This is dog, cat, and lion. Okay, so we keep the dog by the number 0, cat as a 1, and lion as a 2. Similarly, dog, sorry, 0, 1, and 2. This is the confusion matrix we have made. Okay, so if we say that our model is predicted right, means what? These values should be higher. When we talk about, means what, this value should be higher. So we can see the value, what the values are there. So it will be 7, then it will be 21, it will be 13, so it will be 5, 0, 2, 9, and 6, and it is 1. So what is the meaning of this 7? Means that model has predicted dog 7 times, and 7 times it is actually it is right. What is 5? This is 5. What do you mean by this 5? Okay, this 5 is what? 5 times the model has predicted lion, but it is what? It is a dog. Same like there also. 5 times dog is predicted 2. Yeah, 5 times predicted, yeah, 2 times predicted dog, but actually it is a cat. So are you clear with this multi-class confusion matrix, everyone? Everyone, are you clear with this? Okay. Now,
Yes, sir.
hmm. Now we consider types of error. Mm, 30. So we can see that one again. I can model this one. Dog and not dog. Okay, dog, not dog. It is dog, not dog. It is actual, and this is predicted. It is 29. It is 3. It is 4. It is 30. So there are two types of error. Types of error. It is two types. That is type 1 and type 2. Okay. So type 1 errors we can see. Model is predicting dog, but actually it is not dog. So this is what false positive. So this is one type of error. So number of false positive. मतलब क्या, एक्चुअल में डॉग नहीं था, पर मॉडल जो उसको प्रेडिक्ट क्या कर रहा था, डॉग है. So this is a type of, this is a false positive type error. This is a type 1 error. So this is treated as type 1 error. And type 2 error is that डॉग था पर मॉडल प्रेडिक्ट क्या कर रहा था, डॉग नहीं था. सो दिस इज अ टाइप 2 एरर. Type 1, yes. How it is coming, yes. I mean, you are going the wrong way, yes, but predicted not. I think you're in the wrong way. Type 1 is that predicted dog, predicted yes, but it is not a dog. But actually it is not. You can see this one. Okay. And this is what false negative. So this is what number of false negative. So here you can write type 1, not dog, not, but predicted yes. Similarly, type 2, what it is? Predicted no, but yes, yes. Okay, type 2 is that predicted no, but it is yes. So are you clear with this? So by this way, by the confusion matrix, we can see that the types of error कि कहाँ गलती कर रहा है. मतलब कि मॉडल जो है, अगर हम देखेंगे तो मॉडल जो है यहाँ गलती कर रहा है. मीन्स 3 बार जो है डॉग को, जो डॉग है उसे नॉट डॉग बता दे रहा है, और 4 बार जो डॉग नहीं है उसे डॉग बता दे रहा है. ओके, आर यू क्लियर विद दिस? अब नया प्रॉब्लम क्या आया एक्यूरेसी के साथ? अब एक्यूरेसी क्या किया? व्हाट द एक्यूरेसी हैज डन, is misleading. एक्यूरेसी जो है मिसलीड करने लगा. हाउ वी कैन सी दैट? मान लो कोई हमारे पास डाटा सेट है जो कि 99% कहता है नॉट टेरिस्ट एंड 1% कहता है 99 नंबर ऑफ डाटा जो है कहता है नॉट टेरिस्ट एंड 1% कहता है टेरिस्ट. तो हमारा अगर इसका देखेंगे इसकी एक्यूरेसी कितनी आएगी? 99.999%. मतलब हमारा मॉडल जो है 99.99% एक्यूरेट दे रहा है. मतलब या क्या कि हम कोई भी डाटा देंगे वो कहेगा कि वो टेरिस्ट नहीं है, नॉट टेरिस्ट. इसका मतलब तो यही हुआ. अगर हम कोई भी डाटा देंगे तो वो क्या कहेगा कि नहीं ये टेरिस्ट नहीं है. तो ये तो क्रिटिकल, ये तो हमारा क्रिटिकल हुआ ना. क्रिटिकल इंफॉर्मेशन है कि एक भी अगर टेरिस्ट है तो दैट विल बी डेंजरस. So this is what, when we talk about this type of data, this is a imbalanced data. Imbalanced data. Okay. Are you getting this? So handle this type. How to handle this? Then we have come the concept of precision. Then we can come with the recall, and we have come with the F1S. Okay. So this accuracy, what is that? It is misleading. When it is misleading, when we have the imbalanced data. So whenever there is imbalanced data, there we need the precision, recall, and F1S. You got the point? Means we have nothing to do with the accuracy. We have to see कि कहाँ पे error कर रहा है, where the error is there. Okay. Are you clear with this? Everyone, are you clear with this concept? कि मैं accuracy कहाँ पे mislead कर रहा है और कहाँ पे हमें precision की use करनी है जब हमारे पास imbalance data हो. Imbalance data का मतलब क्या कि 99% जो है यस है और 1% नो है. तो हमारा मॉडल जो है मोस्ट ऑफ द टाइम यस ही बोलेगा. ओके. आर यू क्लियर विद दिस? सो वी कम विद द कॉन्सेप्ट ऑफ प्रिसीजन. अब मान लीजिए हमारे पास दो मॉडल है. ये देखो मॉडल, हम ले लेते हैं स्पैम, नॉट स्पैम. ये भी ले लेते हैं स्पैम, नॉट स्पैम. ये मान लो मॉडल 1 है. ये मान लो स्पैम, नॉट स्पैम, स्पैम और नॉट स्पैम. ये मान लो हमारे पास 100 है, ये मान लो 170 है, ये मान लो 30 है, ये मान लो 700 है. ये मान लो हमारे पास 100 है, ये मान लो हमारे पास 90 190 है, ये मान लो हमारे पास 10 है, ये मान लो हमारे पास 700 है. नाउ मॉडल 2. Which model is best? Which model is best? Can anyone tell? दोनों में से कौन सा मॉडल अच्छा है या दोनों मॉडल सेम है? दोनों मॉडल जो है परफॉर्म वेल कर रहा है. दोनों की एक्यूरेसी देखोगे, when we see the accuracy of both the model, It is coming 80%. But which model you will implement? Can anyone tell? Model 1, model 2. Why? Why Rishikesh model 2? The reason? Error is less. Which error is less? Which error is less? Type 1 error. Okay. So type 1 error is less. So what? Oh, that is the technically you are telling type 1 error is less. Okay. But what it means? What it means? यहाँ पे देखो मीन्स क्या है कि जो स्पैम नहीं था, नॉट स्पैम, उसको भी स्पैम बना दिया। ये 30 जो है, ये देखो, ये स्पैम नहीं था, पर प्रेडिक्शन जो है इसको भी स्पैम बना दिया। मान लीजिए आपके पास ऑफर लेटर आया कंपनी का, गूगल मान लीजिए कि अमेजोन जो है आपको 30 लाख का पैकेज का ऑफर लेटर भेजा। मॉडल ने क्या, आपने एक मॉडल लगाया हुआ है स्पैम एंड नॉट स्पैम का, मॉडल ने इसको क्या किया, स्पैम बना दिया। तो लॉस किसको है? आपको लॉस है, क्योंकि आपका 30 लाख का पैकेज जो है मिस हो जाएगा। So this is a critical task. This is the critical conditions. जबकि उसे एरर कम करनी चाहिए थी। So we can see that false positive of A is greater than false positive of B. You got the point? Okay. So, and another thing we can see, यहाँ पे देखो, स्पैम था और उसको नॉट स्पैम बना दिया, तो इससे ज्यादा असर नहीं होने वाला है। So that's why we can go for the model 2. We can go for the model 2, which Rishikesh has done right. Okay. So what is the formula for the precision? Can anyone tell? हमें केवल यही देखना है, यही दो चीज प्रिफर करना है। So it is TP by TP plus FP. याद रखना। Understood? Everyone? Precision is what? TP, केवल हमें पॉजिटिव वैल्यू ही देखनी है। So TP by TP plus FP. Rest recall and F1 scores we will discuss in the lab, in today lab. यहाँ तक किसी को कोई डाउट है तो पूछ लो। Anyone has any doubt, you can ask. इस पे न्यूमेरिकल क्वेश्चंस आएंगे, तो इसलिए आप हर एक वैल्यू को जानो, कंफ्यूजन मैट्रिक्स को, एक्यूरेसी को, टाइप 1 एरर। हम लोगों ने अभी आज का अभी क्या क्या पढ़ा? एक्यूरेसी। Okay, we have studied about accuracy. Then we have studied about confusion matrix. In the confusion matrix, we have seen about the accuracy, then type 1 error, type 2 error. Then third one we have seen what about the precision, and about the which model is best. So these things we have seen today. In the lab, we will see fourth one, that is the recall, and fifth one, that is the F1 export. Okay, and we will do the coding part. So how to calculate the accuracy through the Python code, how to display the matrix, coefficient matrix, everything. और कोई doubt है किसी को? We will see both binary classification also and multi-class also. We will go through the both part. Anyone has any doubt? I will upload this what I'm telling, this slides on the drive. On this drive, I will upload now. I think today which experiment is the experiment number? Last class we have done PCA. So I think today it is 11. Experiment number 11. That is the confusion matrix. And date is 9th April 2025. आप लोग सब वहाँ पे बहुत तेज हैं। Okay, thank you. I'm ending the meeting.